Hello everybody, welcome to Transy Learning Chemistry videos. Today we'll be discussing about quantum numbers, and in that we'll be covering the practice problems related to how to write electronic configuration of elements. In this video we'll be discussing about few exceptions. So let's see what all questions we'll be covering in this video. We'll be writing the electronic configuration of molybdenum with atomic number 42 and silver with atomic number 47. You can see here that on the right hand side I have shown the energy level diagram as per the Aufbau principle, and the basis of Aufbau principle is the Bohr's rule, which we will be following to write the electronic configuration. And here I have mentioned about the maximum number of electrons each orbital can accommodate and the values of orbitals. So first of all, I will write the principal quantum number. Now I will write the orbitals. We will be using the n plus L rule, which is the Bohr's rule, and we'll be using this rule to fill up the electrons as per the increasing energy of orbitals. So here in this case I will fill up 2 electrons, and then I will write the n plus L of all the orbitals, and after that I will compare n plus L. In case of 2s and 2p, the n plus L of 2s is less, so I will fill this first. And in case of 2p and 3s, both of them have same n plus L, so I will give preference to the one which has lower principal quantum number. So I will fill 2p first and then 3s too. Now comes 3p and 4s. Both of them have same n plus L, but 3p has lower principal quantum number, so I will fill this first and this one. And now in case of 3d and 4p, I will fill 3d first. Till here we have 30 electrons filled. So now from the 4p and 5s, I will fill 4p first and then 5s. So this will be 36, 37, 38, and then we are left with 4 electrons, and I will fill here because d orbital can accommodate maximum of 10 electrons. So this is the electronic configuration of molybdenum. You can see here the electronic configuration as for the filling pattern, in which I have filled 4s before 3d and 5s before 4d, and this is as per the ascending principal quantum number. Definitely we will consider this as the final electronic configuration because principal quantum number determines the main energy shell of an atom. But here we have an exception. We know that half-filled and fully filled orbitals are more stable. So if we consider the d orbitals, then the d5 and d10 orbitals will have extra stability as compared to other d orbitals. So if we look at here, then the 5s is fully filled, whereas the d orbital has 4 electrons. So if it gains 1 electron, this d orbital will be extra stable, and this will lead to the extra stability of the orbital as well as the atom. So in this case, this is the expected configuration, but the actual configuration will be 4d5 and 5s1. This is the actual electronic configuration of molybdenum. Now if we want to write this electronic configuration in terms of electronic distribution, then we have to consider 2 more rules or principles, that is Pauli's exclusion principle and Hund's rule of maximum multiplicity. As per the Pauli's exclusion principle, when we are having 2 electrons, they will have opposite spin, and as per the Hund's rule, they will occupy singly, and then the pairing will take place with opposite spin as per the Pauli's exclusion principle. Now I will follow these 2 rules and fill up all the orbitals here. Now the actual electronic configuration is 4d5 and 5s1. So here we will be having 5 electrons with parallel spin and 5s1. In case we need to write the electronic configuration by taking into consideration the noble gas electronic configuration, here the atomic number of molybdenum is 42, so we will consider the noble gas krypton, which has atomic number 36. So I will eliminate 36 electrons from here. So this is the electronic configuration of molybdenum. Now writing the electronic configuration of silver. First of all, I will write the principal quantum number, then I will write the orbitals. Now taking the basis as n plus L rule, that is Bohr's-Bury rule, I will fill electrons in the orbitals with increasing energies. So first of all I will fill this, and then I will write the n plus L of all the orbitals. Now I will fill 2s first, and then 2p, and then 3s, and then 3p, then 4s, and then 3d, and then 4p. Till here we have 36 electrons filled, and after that I will fill this, that will be 38, and then we are left with 9 electrons, so I will fill up here because d orbital can take maximum of 10 electrons. So this is the electronic configuration of silver. Here I have written the electronic configuration as per the filling pattern, and here I have written as per the ascending principal quantum number. We will consider this one as the final electronic configuration, which has the basis of ascending principal quantum number. You can see here that the d orbital has 9 electrons and the s orbital has 2 electrons. We know that the half-filled and fully filled orbitals are more stable, so the elements with configuration D5 and D10 will have extra stability as compared to other configurations. So in this case, though this is the expected configuration, but the actual configuration will be 4D10 and then 5s1. So in this case the d orbital is fully filled. So this one is the actual electronic configuration of silver. Now if we need to write the electronic configuration in terms of electronic distribution, then we have to consider 2 more principles or rules. They are Pauli's exclusion principle and the Hund's rule of maximum multiplicity. So keeping these 2 principles in mind, I will fill up the other orbitals. Now in actual configuration we have 10 electrons in the d orbital. So this is 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10, and we have just 1 electron in the 5s orbital. So this is the electronic configuration of silver as per the electronic distribution. In case you need to write the electronic configuration in terms of noble gas electronic configuration, then all you have to do is to select the nearest noble gas. In this case we'll be selecting the krypton because the atomic number of silver is 47. So this is the electronic configuration of silver in terms of noble gas electronic configuration. Thank you very much for watching this video. For more videos you can visit our website transelearning.com. Have a great day.